Yeah, so this session is for NLP exam preparation. Okay, so just I want to set few expectations before I start. So what we will be doing is we will go as per the modules that ma'am has told that will be coming for the exams, and we have written a very minimum theory. Most of it are numericals, and we have prepared the notes in such a way like we have taken the previous exam papers and how it has come in those exam papers. We have taken those questions topic wise, and then we have put it in the notes. Okay, coming to this subject, this is easy, and I think many of you would have already prepared also, and just the purpose of taking this session is for a revision for you all and for us also, and then it will give you a good start, or people who have already completed the preparation, it will be a good revision, and it will be a very handy go through notes before exams. Okay, so I hope this will be very useful to everybody of us here. And another thing, another expectation, please do not expect we will explain theory. We assume that you all already know the theory, the concepts, the terms. Okay, so we'll be explaining more numerical problems. Those are also solved in the notes. We will be just explaining so that everybody knows how to solve the numericals, and we have for every topic we have done enough number of problems in these notes. Okay, so let's start with the first topic. Just let me check if somebody else is there. I'll just admit these people, and after this I will not. Yeah. Is somebody able to admit others, or it is only me who can admit?
You Anu.
Sorry?
Only you can admit.
Okay, then I'll stop now. It's already we have crossed 10 more minutes. Okay, yeah. So let's start with the first topic. So module 1, as you all know, it is all theory. Okay, and we have seen that in previous paper there are around sometimes 5 marks of paper is come from here, and sometimes 3, sometimes 2. Okay, so here we have written some theory because this is actually important part, so we will just revise this. Okay, so first questions from this topic are majorly related to ambiguities and the levels in the NLP that we have. So when coming to ambiguity, so we all know what is ambiguity. Ambiguity is nothing but ability of understanding the sentence in more than one way, right? So sometimes we have English sentences where we get more than one meaning of a particular sentence, and then we have ambiguity, right? So there are questions on types of ambiguity. We need to identify, they will give one sentence and we need to identify what is the type of ambiguity that sentence has. Okay, for that we need to first understand what are the different types of ambiguities we have. Okay, so first one is structural ambiguity. This is also called as syntactic ambiguity. Okay, so this ambiguity arises when your sentence has more than one meaning. Okay, so ambiguity means itself that sentence has more than one meaning. But now coming, if we precisely talk about structural ambiguity, here this ambiguity arises based on the way the words are arranged in the sentence. Okay, so with this definition you may not understand, but let's see the example. See, Sarah caught the butterfly by the tree. So here in this sentence we if I understand this sentence as that Sarah has caught some butterfly when she was standing by the tree. Okay, someone else can understand this sentence as Sarah caught the butterfly which was fluttering near the tree. Okay, here we have two meanings, either Sarah is standing by the tree or the butterfly is fluttering near the tree. So this sentence has two different meanings, and this is ambiguity here because of the words how they are arranged. Okay, so this kind of ambiguity we call as a structural ambiguity, and it is also called as syntactic ambiguity. So in the exam they may ask you to identify syntactic ambiguity or structural ambiguity, both are same. Next is grammatical ambiguity. So here this ambiguity arises when a word can be used as a grammatically or can be used as some noun, okay, some meaning. Let's say can. Can be a noun, like we say that container, okay, can, okay, and then can be used as a verb also. So here for this word can, we will have a grammatical ambiguity. And next we have a lexical ambiguity. So this ambiguity occurs when a single word is associated with multiple senses. That means in a sentence, if you have a particular word which gives you two different senses, then that is called as lexical ambiguity. So the tank was full of water. I saw a military tank. So both are nouns but have different meaning. So in this case, this sentence has lexical ambiguity. Okay. So this is very important. I am sure that we will have one question from this area in the exam. Okay. And then we have semantic ambiguity. Okay. Now what is this semantic ambiguity? So this ambiguity occurs when the meaning of the word itself is misinterpreted. That means so let's see the example, then only I'll come back to definition. The car hit the pole while it was moving. Now here interpretation can be the car while moving hit the pole and the car hit the pole while the pole was moving. Okay. So now you will say that this semantic and structural look same, right? When I was reading, it looked same to me, but it's not same. Here the difference is, if you see in semantic, the car hit the pole while it was moving. Okay. Now here this it word is there, right? It either it is referring to car or it is referring to pole. So we are not sure here. Okay. So this is called as semantic ambiguity. Whereas in syntactic ambiguity, you have two different meanings, okay, of the sentence itself. But here the ambiguity we have is whether this it is a pole or a car. Okay, that's how you can understand this. Next is anaphoric ambiguity. So what is anaphors? Anaphors are nothing but entities that have been previously introduced in the discourse. Okay, so we don't understand anything with this definition. Let's see the example. The horse ran up the hill. It was very steep. It soon got tired. Here also the anaphoric reference of it in the two situation cause ambiguity, right? So here it can be hill in this case, okay, and here it is nothing but horse. Here it is referring horse in the case third sentence. It soon got tired. So anaphors are the entities that have been previously introduced. So here two times it is introduced. One time it is referring to the steep hill, okay, and another time it is referring to horse. So here this ambiguity, here this anaphor called as it is arising twice, that it has already arrived previously, okay. So it's something like that. Next we have pragmatic ambiguity. So pragmatic ambiguity refers to the situation where the context of a phrase gives its multiple interpretation, okay. So basically not one or two but multiple interpretation you will have for its sentence. Like if you take an example, I love you too. So it can have multiple interpretation, like, okay, simple I love you, like just like you love me, or I love you just like someone else does, or I love you as I love someone else, right? This, because of this word too, you can interpret it in more than multiple interpretations you have here, right? So that is called as pragmatic ambiguity. So we have seen all the kinds of ambiguity that we have. Now in order to resolve this ambiguity, whenever we build any NLP model, so this is the there are few phases that model has to go through, okay. Your NLP, your natural language processing should have, your machine should have knowledge of particular phases, okay, during which that sentence has to undergo this processing, like morphological knowledge. So in this phase of NLP, so what is the purpose of this phase is to break the chunks of a language input into the set of tokens corresponding to paragraph sentences and words. So what does this mean? That means if you have something word like undesirableness, so in this phase of your NLP processing, your machine should be able to break this. How will it be able to break this? Only if it has a knowledge, morphological knowledge, like how it can break it into different morphemes, okay, like prefix, stem, suffix. Like undesirableness, you can break it into undesirableness, like that, okay. So that is called as morphological knowledge, okay, breaking your chunking your words into different morphemes. Next you have lexical knowledge. So we have seen lexical ambiguity, right? So similarly it should be able to identify that lexical ambiguity. So here it concerns with the words and categorizing them. That is, it is a process of understanding what that word mean, in what context that word is used, or we need to understand the relationship of one word to another. That is called as lexical knowledge. Next you have syntactic knowledge. So in order to resolve that syntactic ambiguity, in this phase machine should know how words can be put together to form a correct sentences, okay, and determines what structural role each word plays in the sentence, okay. So that is nothing but the machine should be able to understand the arrangement of the words in a sentence, okay. Like if you see large have green ideas nose, is it correct syntactically? No, it is lexically correct. Why it is called as lexically correct? Because there is no word which has two different meanings, right? But here it is syntactically incorrect because there is no structure of the sentence at all. It is not making any meaning, okay. So it is lexically correct but syntactically incorrect. So machine should be able to identify that, okay. Next is semantic knowledge. Now in semantic knowledge it refers to meaning that is conveyed by the input text, okay. So here in syntactic it does not care about the meaning, whether meaning is coming out or not. It just looks at the arrangement of the sentence, whether it is arranged grammatically correctly or not, okay. But in semantic knowledge it also checks whether there is some meaning coming out or not, okay. Now if you modify this sentence, green ideas have large noses, so now this is syntactically correct but semantically incorrect, okay. So now the arrangement is correct as per the grammatical ways of the English, but when we talk about meaning, there is no meaning of this sentence, right? So semantically it is incorrect. Next is pragmatic knowledge, okay. This is nothing but how the sentences are used in different situations. So nothing but pragmatic level of processing, it deals with the real world knowledge. That means she cuts banana with a pen, if we take this example, okay. This is correct semantically, lexically, syntactically, every way it is correct, but it is pragmatically incorrect. Why? Because if you see in a real world, do we cut banana with a pen? No, right? So it tries to process your sentence based on its knowledge of the real world, okay. So that's where this is pragmatically incorrect, but other way it is a very correct sentence, okay, when you talk about other knowledges. So this is the fifth level. After it undergoes the semantic processing, it undergoes pragmatic processing where it fails this sentence. Next is discourse knowledge. So it concerns with how the immediately preceding sentences affects the interpretation of next sentence, okay. It deals with the analysis of structure and meaning of the text beyond a single sentence, making the connection between the words and sentences. I know you have not understood this. Let's see the example. I love Domino's pizza because they put extra cheese, she said. Now here there are two entities, she and Domino's. Okay. Now she is in the context of I and they is in the context of Domino's. So discourse will interpret this sentence as two entities, I and Domino's, and two anaphors, she and they. Now in this it should have the knowledge to identify that she is used for I and they is used for Domino's. Okay, so here discourse is nothing but the knowledge to understand what the preceding sentence has effect on the second sentence. Okay, so basically you should be machine should be able to relate I with she and Dominoes with they. So that is nothing but the discourse knowledge. So I hope you might have got the brief idea. Now let's go on to the questions. So this we have taken from the previous exam papers. Now if we see first question, for each of the following sentence, please identify whether they are lexically, syntactically, semantically and pragmatically correct. Now based on the understanding that we have studied just now, eats ice cream I in summer. Okay, now if you see this line, this sentence, if we go one by one all the ambiguities that we have seen, all the knowledges that we have read, there is no word which has two different meanings here. That means it is lexically correct. Okay, but it is not correct syntactically or semantically. Coming to fruits are flying in the blue sky. Okay, you should mention all the whichever way it is correct, you should mention all of them. Now fruits are flying in the blue sky. So if you see there is no grammatical mistake in this sentence, right? But it does not make any meaning. Okay, semantically it is not correct. Fruits cannot fly, right, in the blue sky. So it is lexically and syntactically correct. Now baby is eating the chocolate. So this is lexically, syntactically and semantically correct. But pragmatically is it correct? Baby is eating the chocolate. Because a baby cannot eat the chocolate, right? I mean, if we think it's a small baby. That's how I understood based on the answers.
Anu, just to
Yeah.
clarify,
Yeah.
this is baby cannot eat a chocolate wrapper. It's not even baby. Chocolate wrapper is not meant to be eaten.
Yeah, that's what that's how I also understood. Baby is eating the chocolate wrapper. In real world, it is not correct, right? So that's
Yes,
why it is.
wrapper is not meant to be
Yeah,
eaten.
that's why it is pragmatically incorrect. Okay. So this is first question. Second question. So I'll be going little bit fast because if you see we have 75 pages to finish it. Explain which type of ambiguity exists in the following sentences. I saw someone on the hill with a telescope. Now the first page that we read about all the ambiguities. So if you see here we have I saw someone on the hill with a telescope. So here two meanings are coming. Whether I saw somebody with a telescope, I have a telescope and I saw somebody on the hill, or I saw somebody on the hill who is having a telescope. So that's where it is a structural ambiguity, nothing but syntactic ambiguity. Okay. Next is she is walking towards a bank. Here it is very clear. We have a bank word which has two different meanings, and so it is a lexical ambiguity. So bank can be the bank of a river or a normal bank. Okay. Next is running race was wonderful to watch. The answer is grammatical. Okay. Why grammatical? Here race and watch has both noun and verb sense. Okay. So that's why it is a grammatical ambiguity. Find out the type of ambiguity, lexical or syntactic, and justify. Okay, I have not given any justification, you can write, but Nicole saw the people with binoculars. So it is very clear this is a structural ambiguity, right? It's the same sentence like we have with the telescope. Okay, either Nicole has a binocular, or a people whom he saw has a binocular. So two ambiguities are there here. So that's why it is a syntactic ambiguity, because they explicitly mentioned these two, lexical and syntactic. So you should mention syntactic only, don't mention structural. Next is they went to bank. So this is also again a lexical, because we have a bank word here. So I have given just a very brief idea on this one. Maybe you can go through in the Google. We have many different sentences. If you just type give some sentences about with the lexical ambiguity, so when you go read about those sentences, you will get more idea. Okay, so next let's move on to the second module. So in this module we will have bigrams, n-grams kind of questions that will be given, okay, from those topics. And then there are some topics related to smoothing, Laplace smoothing, perplexity. Okay, so let's go with this module now. So I just wrote some basic theory. So this is conditional probabilities, like everybody knows, right? So here nothing but P of B given A is given, probability is calculated as probability of B given A is calculated as probability of A comma B by probability of A. That is nothing but your probability of A and B together, and then only the probability of A. So that's how we calculate the probability of B given A. So similarly, for if you have probability of A comma B comma C comma D together, if you have to calculate, then it is something like probability of A into probability of B given A into probability of C given A comma B, probability of D given A comma B comma C. So basically this is a chain rule. Okay, so this is defined here in NLP in this way. Basically it has a application based on the probability of calculating the probability of a word given the previous word. So it is something like that. Let's say if you want to calculate the probability of a sentence, okay, or a sentence which has different words like x1, x2 up to xn, then you gonna calculate it something like probability of first word being the starting word, and then into the probability of second word given the first word is coming before this x2, and then probability of x3 is that x1 x2 is coming before x3. Similarly probability of x4 given x1 x2 x3 is coming before x3. So that this is a chain rule to compute the joint probability of words in a sentence. So you just need to remember that if you have to calculate the joint probability of a, the probability of a complete sentence, it should be in this order only. You cannot disturb this order, then only you will get the correct probability of the arrangement of the words in a sentence. Okay, so this is based on this chain rule is based on this conditional probability formula, wherein you calculate the probability of A comma B as probability of A into probability of B given A. Okay, similarly probability of A comma B comma C comma D will be calculated as probability of A into probability of B given A, then probability of C given A comma B. So based on this formula, this chain rule is derived. Okay, so now we have different models. In order to make use of this chain rule, we can have different models called as n-gram model. Okay, it is nothing but a continuous sequence of n items. N-gram model is a continuous sequence of n items from a given sample of text or speech. Okay, and then based on this n-gram model, you can find out the you can predict, okay, if you want to predict what will be the next word in a sentence, or if you want to find out the sequence of the words. Okay, so this is very important. Now in n-gram model we have different models like unigram, bigram, trigram, 4-gram, 5-gram. Okay, in unigram you do not use any history. That means this is called as 1 gram. So you don't even bother what comes before W2, what comes before W3. Okay, it is a unigram model is calculated. The probability if you use unigram model is calculated individually, like probability of W1 into probability of W2 into, so we will see examples, then it will be more clear. And coming to bigram, here in bigram, here in bigram you will use previous history. Like suppose you have in a sentence word 1, word 2, then word 3. So in bigram the probabilities will be calculated based on the history. That means probability of W2 will depend on W1, probability of W3 will depend on W2. Okay, that is bigram. And when it comes to trigram, two words history is used. That means probability of W3 will depend on W2 and W1. And if you have another fourth word in the sentence, then probability of W4 will depend on W3, W2. Okay, previous two words history will be taken into account when you are calculating the probability of any particular word. So that's how 4 gram 3 words history, 5 gram 4 words history. Now let's see the example of unigram. Okay, so unigram we said that there is no history required. So if you have to calculate a probability of the sentence which has, let's say, some words, then it is nothing but the pi of p probability of wi. That means it is nothing but the multiplication of all probabilities of all the words, like probability of I into probability of want into probability of to, probability of eat into probability of healthy into probability of food. So that is nothing but the unigram probability of a sentence. Now if you use bigram model, then you calculate the probability by considering the previous history. Okay, so that means if you have to calculate the bigram model, if you have to write a bigram model of a sentence, then how you have to write is probability of word 1 and word 2 is given by, now this is based on the chain rule. So probability of W1 and W2 will be given by probability of W2 given W1. That means probability of W2 given W1. So if you take so many words in the sentence, then it will be something like probability of Wi given Wi minus 1. So you should read it like this. So that means your previous word is let's say if you have W1, W2, W3, if you have 3 words, then your bigram model will use the previous history. That means your bigram will be probability of W1 based on the chain rule into probability of W2 given W1. That means your previous word is W1, then you are calculating the probability of W2. Similarly for W3 it will be probability of W3 given W2. So let's take the example. If you take this sentence, here you will calculate the bigram model. The formula for bigram model, how will you write is probability of I given that it is the start of the sentence. Okay, so you always have to consider the start. So here before I we always have something called start tag. Okay, so here you need to see that when you are checking, you need to check while you are calculating this, you need to check whether I is the start of the sentence. Okay, then probability of want given I is the first, I is the previous word before want, then probability of to given want is the previous word to. So similarly so on for eat, given that to is the previous word, healthy, given that eat is the previous word, food, given that healthy is the previous word. And then at the end you also need to, in the exam they will, in the question they will give whether you have to consider start and end. If they give you have to consider start and end, then you need to take this probability also into account. Okay, probability that food is the ending word. So this is just the example of how you write your unigram, bigram. Okay, we will see where we are using this, okay, in further questions. So basically we call it as a maximum likelihood. So how do you calculate these probabilities? want I, probability of 2 given want. It is nothing but count of, this is the sequence, okay. So now if I want to calculate the probability of want I will check count of, so what is my previous word? I want. In my corpus, they will give you some corpus. In my corpus, how many times I got I want together by count of want. How many times I got, sorry, count of I. Your I minus 1 is, your previous word is I. So how many times I got I, and this is nothing but the count of how many times we got I want together. So that will be the probability of want given I be the previous word. So that's how you call, this is called maximum likelihood estimate formula. So let's see the example. Now let's say this is the corpus given to you. Okay, this is the corpus given to you. Now if you have to calculate the probability of I being the starting sentence. So how many sentences we have totally? We have 3. And how many times I came in the starting? 2 times. So 2 by 3. Similarly, if you want to calculate probability of Sam being the starting sentence, starting word. So how many times Sam has come in the beginning? It came only once. So 1 by, total number of sentences are 3. So 1 by 3. This is wrong here. Okay. 0.5 answer is wrong here, I think.
So actually, what I feel that Sam should be the number of Sam appearing. So it is 2. So it is 1 by 2 is correct. Hello.
Yeah. Correct.
Yes, it is correct.
Yeah, correct. This is to
Anu,
3.
please allow everyone. Most of them are waiting.
Oh, okay. Yeah. Sorry, even I told here, right? It is nothing but the count of how many times that word, the for which we are calculating the probability, how many times it has come. Okay.
How did it become 1 by 2
No.
again?
It's I minus 1. I minus 1. So it should be starting tag only.
No. It
Count
should
of
be
is starting.
3 only. It shouldn't be 2. What I understand is we have to see the probability of this. Okay. So how many sentences are there? 3, right? So 3 here. So here also how many sentences are there? 3. So you have to take 3. So you need to,
Anu,
yeah.
no, the problem, it is not that way where the way you are, explaining it. Is the number of times that particular word has appeared in the corpus.
No.
Right.
No.
No.
Number of times it is at the start. Number of times
Yes,
Sam is
yes.
at the start.
It
That
is
is
in the
what we
numerator,
mean.
na? It will be in the
Hello.
numerator number of times how many it is after start. But
Hello.
number of times
See
it has
here,
appeared corpus is 2. Is it
I,
correct?
Hold
that thing that's
on. We will
Anu,
discuss
you have,
this. Please keep writing whatever you think is wrong or a discussion required. We will see when we have the when we will complete this module. Okay.
I think Anu, you have explained nicely in your theory part. Now you are a bit confused.
No, it's all right. Point 5 is correct.
That is correct. 1 by 2 is correct. Because Sam has appeared twice in the corpus. In the third sentence, there is no Sam.
Okay, we will discuss
And
this. We'll park it. We'll discuss this. Okay. Let's go further. So next we have probability of am I. So basically I am. So I am has come 2 times. I am here. I am here. Okay. And then we need to see how many times I has come. I has come 1, 2, 3 times. So 2 by 3. Okay. Now if you see here, probability of Sam being the this is nothing but probability of Sam being the ending, the end word of the sentence. If you see here, how many times Sam has been ending? It's 1 time. Okay. So 1 by, maybe people who were saying is correct. So Sam, total number of times the Sam has come is, so now in this case we will see Sam how many times it has come. No, I was only correct. Here it should be 3 only. Here if you see how many times Sam has come 2 times. So 1 by 2. So if you see do I, now if you see do I, here how many times we have I do one time only, so one, and then how many times I has come 1, 2 and 3 times. So my understanding is you need to, in your denominator you will have the probability of count of this, okay, and here how many times this sentence we have, in this we have this sentence, I mean how many sentences we have 3 sentences, but maybe we will park it and we will discuss this, okay. Yeah, next we have this. This is again I have written some more example. How do you calculate bigram? Okay, one word history, two word history, just to understand. I mean, make you understand that how we are going to write the trigram and bigram, and how, what is basically how we calculate this. Like count. This is nothing but count of above 5 minutes from college by count of above 5 minutes from, count of this part in the denominator, and in the numerator count of above 5 minutes from college, okay. This whole sentence you need to check in your corpus. So this I am skipping, so this is just a self explanatory. Next, let's move on to the questions. So after I finish the questions of this module, we will have 10 minutes for discussion, okay. Next is write the formula to calculate the unigram, bigram, trigram probability of this sentence. So now here what we have to do, we have to write the formula for calculating the unigram probability. So if you see here, this is a sentence given, and we know in unigram no history is required, okay. You need to just simply write the probability of each word. Probability of life should be great rather than long. So this is nothing but unigram. It's very simple. Coming to bigram. Now bigram, it starts with the life, probability of life being the starting sentence, okay, the starting word, and then probability of should, life being the previous word, probability of be, should being the previous. So you should go one by one for each word, and then you should take the previous word as your given, and then you need to write the probability of the incoming word. So that's how you need to do till the end. You can also add, if they ask in the exam consider starting and end, then you need to add one more probability, saying probability of then being the ending sentence. So this is something like this, being the ending sentence. So you can add this, okay, if they ask. Now in trigram, so it is something like probability of life, okay, given. So this is how it is given, okay, in the answer key, but I really didn't understand the meaning of this. Basically we should consider two previous history. So in the two previous, if you go, you should take the probability of, basically they are trying to include the probability of life word also, okay. So it is nothing but probability of life, it being the starting sentence. So just to make it two words history, they mentioned it 2 times, okay, here. That's what I understood. And here into probability of should, and the previous 2 cases it will be life. So here it means life being the starting sentence, okay, starting of the sentence. And then probability of be, where should life. So it is something like life should be, you should read it like this, life should be, that means 2 previous words should be life and should. And then should be great, so should, 2 previous words should be should be. So that's how you need to write the formula for trigram. You need to consider 2 words in your history. Next is how many trigram phrases can be generated from the following sentence after replacing punctuation by a single space. So you be careful when they mention punctuation by a single space. So here if you see how many trigrams will be formed, let's see. So you should always consider starting of the sentence, okay. Then first set will be starting of the sentence and natural language. Next will be natural language processing. Next will be language processing is, okay. Next processing is very interesting, okay. Then very interesting though not, next will be interesting though not, and then next will be though not easy. So you need to just consider in every this one word, okay, extra. So that's, so now how many trigrams have come? 1, 2, 8 trigrams totally, okay. They mentioned in the answer key one more answer, 9 also is the correct answer. So if you consider ending of the sentence, then it will be not easy and then ending, okay, and then ending as we have considered starting. So in the answer key they mentioned 8 and 9 both are correct answers, okay. Next, yeah, this one. Now if you see here, they have given this corpus, this training set. This is the training set. Now using this training set, we need to compute the probability of this sentence. The Arabian Nights are the fairy tales of the East, okay. So now take one by one word you need to take. Probability of the being the starting sentence, and they used bigram model, okay. So most all the questions they have used bigram only. All the previous exam paper they have given bigram only. So the being the starting sentence. So how many sentence, now if you see in your training set, how many times the is in the starting? It is 2 times. Okay, 2 times. And totally how many times the is, it's not totally how many times the is coming, it is how many sentences we have. So 3 sentences. So 2 by 3. Now coming to probability of Arabian given the, be the previous word. That means you should read it like count of the Arabian divided by count of the. Okay. Now how many times the Arabian has come? 1 here, the Arabian here, and then you have the Arabian here 2 times. And how many times the has come? 1, 2, 3, and there are 4 and 5. Then this is wrong. Here this is wrong, okay. This should be 2 by 5. 5 times we have the. Then probability of nights given Arabian, okay. Now you need to read it as Arabian Nights. 1. So how many times it has come like this? Arabian Nights 1, 2, 2 times, okay. And then how many times Arabian has come? 1 and 2. So 2 by 2. So similarly you need to calculate for each and every word till the end, and then you need to consider the ending also. That means probability of east being the ending word. So east has come ending word in only one sentence, that is here. And if you see here, east being the ending word is 1, and how many sentences we have totally? 3. So 1 by 3. Okay. So then finally once you find out all the probabilities, then you need to multiply all the probabilities together. That will be the probability of your sentence, complete sentence. So that is, now you might have understood why how we are using this to calculate the bigram probability, how we are using this bigram model to calculate the probability of a sentence. Okay. Similarly, I have not solved this completely. So here also you can solve the same way. Just for each word you can calculate the bigram probabilities. Okay.
నాకు 3 to 4 hours క్లాస్ ఉంది ఒకటి, అది చేస్తున్నాను.
Please mute yourself.
సో ఏమనుకోకండి, నేను క్లాస్ 11, 12 అవుతుంది. తింటలేదు, రాజశ్రీ తెస్తుంది.
Yeah. Next is perplexity. Okay. Next we talk about perplexity. So perplexity is nothing but best language model. So here why we use perplexity is to find out whether your language model is a good model or not. So basically it is the one that predicts the unseen test set properly. Okay. So that means if your probability is maximum, then your perplexity will be minimum. So this is just one topic that is they have given, and there are few questions that have appeared in the previous exam. So the formula is simple, like perplexity is given by probability of your sentence raised to the power of minus 1 by n, where n is nothing but your how many number of words that you have. Okay. Now if you just take this question, so I am not going the theory part of this, the significance and all. The significance is that it is nothing but a test measure. It is just a evaluation measure of your model, wherein you find out whether your model is a good one or not. And here you are nothing but maximizing the probability and minimizing the perplexity. So if you see here, if a sentence, let's say, consists of random alphabets, okay, it has mix of capital and uppercase and lowercase, and we know that we have 26 letters, right, in alphabets. So now when you have both uppercase and lowercase, total number of letters will be 52 in a sentence. It says that it has occurred, all the letters has occurred with equal probabilities. Okay, so equal probabilities means for each letter the probability of occurrence will be 1 by 52. Okay, for each letter. So now here this is your letter, okay, A, okay, then your small a is W2, something like that. So now if you want to calculate the perplexity, how many total you will have? 52. So for each the probability will be 1 by 52. So you will be multiplying each of these. Let's take, we are taking a unigram model. So when you take unigram model, how will you do? Probability of 1 by 52 into probability of 1 by 52 into like that, right? So 1 by 52 power 52 will be your inner probability calculation of all the words together, or your complete sentence. And then perplexity formula has minus 1 by n. So n number of words, how many you have? 52. So when you solve this, your perplexity will be 52. Next is Laplace smoothing. Okay, now this Laplace smoothing we use sometimes if we get the probability as 0, answer as 0, when you calculate using your whatever model, unigram, bigram, if you get answer as 0, then we need to go for some techniques to remove this 0 and bring some value here. So there we use something called smoothing, called Laplace smoothing or add one smoothing. Okay, here nothing but we pretend that we saw each word one more time. We have not seen, but we just pretend. So that is nothing but a smoothing, right? We are adding 1 here. So how do we calculate this? This is your MLE estimate formula. This was your formula, right, for calculating the probability. If you take any bigram model, this was the formula. So what you have to do, if you have to add one estimate, in the numerator you add 1, and in the denominator you need to add v. V is nothing but number of unique words in your corpus, in your training data that they will be giving. Number of unique words, how many you have, that many you need to add here, and at the numerator you need to add 1. Let's see some example to understand clearly. Now this is the example from a previous exam question. So given the following toy corpus, calculate the probability of a sentence using raw bigram probabilities and using Laplace smoothing. So you need to calculate with smoothing and without smoothing both. Now this is your training corpus. Now if you have to calculate without smoothing, okay, now you need to calculate for each, this is the sentence, I am studying NLP. For this sentence you need to calculate probability of I being the starting. So I is starting in 1 and 2, and how many sentences we have? 3. So 2 by 3. And then you have to calculate for am. Am has come how many times? 1 time. Okay, and I has come how many times? Sorry, I am has come how many times? 1 time, and I has come 1. Here again it is wrong, it should be 2, okay, not 3. I has come 2 times. Okay, next, studying am. Now how many times am studying has come? 0. So this is also 0. Now how many times NLP is the end? NLP is at the end 1, 2 times. So 2 by number of sentence, number of times NLP has appeared as the end is 2, and how many words NLP with the name as NLP are there? 3. So 2 by 3. Now with the smoothing, now when you have to calculate with the smoothing, you need to add 1 in the numerator and number of unique words in the denominator. So if you see how many unique words we have, I love to 3, 4, 5 and 6 and then 7 we have, okay, in your training corpus 7 unique words. So then for each word you just add and then calculate. In this only you need to add 1 at the top and 7 in the denominator. Just correct this one. This is not 3, this is 2. Okay. I think 1 or 2 more, yeah, then we will take some discussion where we had doubts. This one more we will see. See, given a corpus C, the maximum likelihood estimation for the bigram hello world is 0.3. Okay. Now they have given us MLE, that means they have given the probability of word hello world, okay, hello world sentence, that is nothing but 0.3. That means this is nothing but the probability of world given hello being the previous word. They have given 0.3, which is nothing but count of hello world divided by count of hello is given as 0.3, and the count of occurrence of the word hello is 580, and then they have given the count of word hello occurrence 580. Okay. Now what do you have to calculate? For the same corpus, the likelihood of hello world after applying the add one smoothing is 0.04. What is the vocabulary size of corpus C? Basically they are trying to they are asking the vocabulary size, means number of unique words that you have in your corpus. So in order to find the number of unique words, nothing but you need to find out the value of V. Okay. So we know the formula of Laplace smoothing, which is nothing but count of your whatever sentence in the discussion plus 1 divided by count of this plus V. Now we know what is the count of hello world. We know count of hello. Okay, we know this complete count of hello world by count of hello is nothing but 0.3. Okay, so from here we will calculate the count of hello world. Count of hello world we got from here, that is 174 plus 1 is nothing but your Laplace smoothing formula divided by count of hello is given plus V. This value after adding smoothing, they are saying that we are our likelihood value is, our probability value is 0.04. So this is what we have equated to, and from here you can calculate your V, which is nothing but the size of the vocabulary in the corpus. Okay, I hope till here it is clear. Now I will unmute, but please go one by one, and till here whatever doubts we have we can discuss, and then we will go further. We have so many things to complete, so not more than 5 minutes. Okay, after 5 minutes I will just do I'll mute everybody again. Yeah, we can go. You can ask me which page we want to discuss from, anywhere.
First
Yes.
of all, check your recording is going on or not. You said it will be done in parts, right?
Yeah, it is going on. I will stop it once we discuss this, and then I will start again.
Okay, thanks.
Yeah, Anu, one quick question. On page 11, if you can go, please.
Yeah.
There was an example which talks about natural language, right? At the bottom.
Yeah, this one. Yeah.
Yeah. Not this, or maybe page 10 bottom.
Yeah.
Yeah, here. Why did we consider natural language together? Why not natural separate and language separate while calculating these trigrams? Because they are, yeah. So if you see in the example, you took natural language as together, right?
It's not
So it should be like
it's not together. It is basically how many trigrams are coming. Basically, if you see trigrams, how do we do? We calculate trigram like 3. You need to take the pair of 3. I mean set of 3. So basically,
correct.
now yeah. So here, if you see.
So when we start, right, we should take in trigrams, right? We should take starts twice, S and then natural as one. Right?
Yeah,
and then
correct. So that's what I'm saying. If you see in this example, they have taken twice only. Okay, But in this yeah, so you are correct. Okay, we can take that also. That's what I'm saying. They are saying number of trigrams can be 9 also, can be the answer, but this is the answer from the answer key that I have done. Okay, taken. So I
Okay.
think they are okay with both the answers.
Okay.
Yeah.
Yeah, nine in the case when we take the end parameter, but it could be more also, right? When we start with two starts, then it could lead to 10 or 11. I mean, based on
Yeah.
what I see. But
Yes.
yeah, that's fine.
Uh, Anu, I have a question on the similar front, right?
Yeah.
So let it be bigrams or trigrams, right?
Yes.
If you go by the chain rule, I mean, if you can scroll back to your first page where you have chain rule mentioned, right? So if you go there, so even I was reading the same thing on the external resources on Google, okay? So if you see there, now it says that P of x1 to xn will be P of x1 given P of x2 if x2 given x1, x2 given x1, x1, something like that, right? If it is bigram, okay, so we stop at x1, right? You have P of x1 into P of x2 given x1, P of x3 given x2, correct? So what I've seen in like some of the numericals is that if you solve it, if you applied it on the corpus, right, and for the P of start, we should calculate P of start. So that's a unigram. Unigram multiplied by the bigram. So in when it comes to trigram, it is first unigram, which is P of start, multiplied by the bigram, which is P of the next word given start. Then comes the trigram.
Yeah.
So that makes sense. But like in the numericals that you have, like you have been going over, you have taken two starts, like P of A given start. So I am not sure, like if you've taken it from the answer key, I'm not sure whether that is valid itself, right?
Yeah, that's what I'm saying. This is little ambiguous here. Somewhere they have taken two starts, somewhere they have taken only one start. Okay.
Because that doesn't make sense to me. Because I mean, I'm not sure if the answer key that they have given, we can talk about that. But what I see here is that like it should be P of start into P of life given start into P of what is that? Was that life given start, right? Then P of should given life start and life. Something so the order of the word should also matter, right? So something like that.
But I mean, yeah, I referred to some other materials. Trigram, they are taking only one start, okay, one word and one start. That is the previous. That is nothing but the history. So that is nothing. That only makes sense, right? History means your life being the starting word, okay. So, but in the key they have used two starts. I don't know about this one. Maybe we can further check this one, okay.
Maybe I can write it to maybe Chetana ma'am, just because I have this doubt. So I write to Chetana ma'am
Yeah,
and like
please,
let's see what she
please
says.
let everybody know. Okay. Yeah, fine.
This,
Let's go further. Then maybe.
only one.
Yeah.
This only one start.
Yeah.
Because if you look at the bigram also we are using one start when two words are required. So if you follow the same logic, when the previous probability when you are multiplying, only unit probability will multiply with that, all the bigrams. So the same way, if you look at that, it should be only one start.
Yeah,
Correct.
fine. Then let's conclude once ma'am confirms. Okay.
Yeah.
Let's move on now.
Okay, Anu, just before
Sorry, somebody was asking something, but keep with you. We will take it afterwards. Okay. Yeah, next is module 3, that is hidden Markov model, wherein we will study more about the parts of tagging, the transition probability, emission probabilities. Okay, so now I am directly just jumping onto Markov chains. Okay, in Markov chains you will have different set of states. Sorry, I forgot to stop the recording here. Let me first stop and then we will